AB Calculus Note Card 45, Second Derivative Test. This is the 45th video lesson in the series inspired by Stacy McMullen, formerly of Dallas Independent School District, who developed this note card system. The second derivative test. The second derivative test is helpful to use in determining the relative maxima and minima of the original function. Let f be a function such that f prime of c equals 0, and the second derivative of f exists on an open interval containing c. If f double prime of c is greater than 0, which means concave up, then f of c is a relative minimum. If f double prime of c is less than 0, or in other words, concave down, then f of c is a relative maximum. So that would look like this, right? And concave up would look like this. So we'd have our relative minimum and relative maximum respectively. And if double prime of c is equals 0, then the test fails. Use first derivative test. And we have a couple examples. These should go pretty fast. Helpful analysis tool. If f has a critical number at x equals 2 and f prime of 2 equals 3, then what can you conclude about f at x equals 2? Let's talk about critical numbers for a second. In critical numbers, there are two possibilities. One, which is more common, is you have a critical number where f prime of x is equal to 0. Okay? Two, where f prime of x is undefined. Now, in our instance, since f double prime of x is defined, we know that we're talking about this case here, where f prime of x equals 0. So we can conclude that f prime of 2 is equal to 0, because that's the only possibility of critical number that we have. And we know also, we're given that f double prime of 2 is equal to 3, and 3 is greater than 0. And going back to our test here, if we have f double prime of c greater than 0, we are concave up. So let's continue here. f of x is concave up. And what that means is that we have this kind of shape here, and we're going to have a relative minimum. So therefore, and dot, 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 f of 2 is a relative minimum. And it's because of second derivative test. So just a helpful, quick analysis tool. Let's go to our second problem. Using the graph of f double prime below, what is happening at f of 1 if f prime of x equals 0? And here we have f prime of x equals 0, so this is a critical number. And f double prime is defined. In this case, f double prime, of which we have the graph here, is below the x-axis. In fact, it's going to be like negative 2.2. So at x equals 1, right? f prime of x equals 0, and since f double prime of 1 is less than 0, what happens? Go back to our chart here. Less than 0, then f of c is a relative maximum. Then f of, in this case, 1 is a relative maximum. We can just for authority say, according to second derivative test. That's all I have here today on this. Very, very simple thing. Go really fast. And it's just kind of getting used to it. So I hope this video lesson has been helpful to you. Good luck, and thanks for viewing.